Hello, everybody. My name is Andrea, and my partner Alexander and I are going to discuss briefly our assigned project, which is predicting maintenance needs for used solar energy systems. Dr. Bosman is going to be our project advisor for this summer. She has a PhD in industrial engineering and is currently an assistant professor at Purdue University. This has been since 2018. Initially, Dr. Bosman exercised her career in the manufacturing industry. Some of the world-class companies where she has worked at are Harley-Davidson, John Deere, and Oshkosh Defense. Now, moving to some of the research grants and awards Dr. Bosman has received are number one, Growing Engineering Educators, Entrepreneurial Mindset through an SOTL-focused writing experience in November 2021. And number two, using bioengineering and bio-inspired design to integrate the entrepreneurial mindset into the engineering classroom in November 2021.
Our student team members are Andrea Guzman, who is in her third year of industrial engineering at University of Puerto Rico and Maya West, and Alexander Vizcarrondo Ortega, who is in her senior year of industrial engineering at University of Puerto Rico and Maya West too.
In this slide, we're going to discuss the significance for this research. Weather stations and satellites record real-time weather parameters. With the use of historic data on solar irradiance and temperature, a site-specific forecast model can be developed. The models will be able to predict solar electricity production at different and individual sites. This is a pertinent and significant issue given the fact that the efficiency associated with solar energy production and distribution has increased. This has provided the conditions so that local homeowners are not only consumers, but now have turned into energy generators as well. Electricity providers now have this additional factor to take into consideration when planning their energy distribution. However, there is little knowledge on how this factor can impact the demand and supply of grid electricity managed by electricity providers.
Moving now to the hypothesis, electricity providers require now more than ever a predictive decision support tool to help them level out the forecasted load demand and supply so further grid disturbance due to solar generation can be prevented. The experimental plan consists of using historical weather data from National Renewable Energy Laboratory, real-time weather data from local weather stations, and forecasted weather data from National Oceanic and Atmospheric Administration to develop and validate models to predict weather data for a specific location. It will be developed for regional impacts. This allows estimating the solar energy generation under those parameters of that location and measuring the impacts. An example of this can be the rainy or cloudy days where the efficiency is not the same as a sunny day. Also, days that are extremely hot affect the efficiency too. The final purpose of this research is to assist energy providers to lever their electricity demand and supply.